How are you all? I hope you all are fine and safe at home. So, today we are going to start a new topic, that is chemistry of benzene. So, let me share these PPTs first, and then so today's topic is benzene and its structure. As you know, benzene molecular formula is C6H6. It is the first member of aromatic compound. Look at the structure. This one is benzene. 6 carbon atom, 1, 2, this 3, 4, 5, 6 carbon atoms are present at the regular hexagon, and to each carbon one hydrogen is attached, in which there are alternate single and double bond are present. This one is a single covalent bond, double covalent bond, and then single, double covalent bond, again single and double covalent. So alternate single and double covalent bond are present, or you may see in this structure also. So benzene, whose molecular formula is C6H6, is the first member of aromatic compound. It is first isolated from coal tar by Faraday in 1825. Coal tar and petroleum are the two main sources of obtaining benzene and its derivative on industrial and commercial scale. Now look at this, you say that C6H6, but in real sense when we say that hexane or any carbon which is containing 6, whose hexane's molecular formula is C6H14, or it may be C6H12 in case of alkene or in alkyne, but here hydrogen number is much less as compared to others. Why this is so, uh, uh, commonly we may call it as, this is just because benzene is highly unsaturated compound. Why this is so, we will discuss this later. Before we are going to explain preparation of benzene. So first let us discuss some properties. As benzene is immiscible in water, it is colorless liquid having boiling point 80 degree, highly inflammable, and burns with smoky flame. It is toxic compound undoubtedly, and it may cause blood cancer also. It is used, so it should be handled with proper care. It is used for the manufacture of nitrobenzene and dyes. It Benzene shows the resonance. What resonance is? Resonance is the concept as, uh, when two or more structure that can be written for a single compound, like the aromatic one benzene, if two or more structure can be written for a compound without disturbing its atoms, so that is known as resonance. And I also discussed something, I use the word, let me clear it first, then we'll go further. Because as I said, the benzene is aromatic compound, so you should also know its aromaticity. Like, these are the cyclic compounds having alternate single and double bond, as I told you, show the resemblance in chemical behavior with that of benzene, all the aromatic compounds. So they give substitution reaction rather than addition reaction. This characteristic behavior is called aromatic character or aromaticity. We have some necessary conditions for aromaticity, like compounds must be cyclic or planar, highly unsaturated, but resistant to addition reaction. Usually they are stable, as shown this one. They undergo electrophilic substitution reaction. We will discuss in our next session about the electrophilic substitution reaction, inshallah. They must obey the Huckel rule. What is Huckel rule? That is 4n plus 2 pi electron. when we'll be doing it's somewhat like problems I'll give you, then you will understand. Now let us do some preparation. One of the preparation of benzene is by from coal tar. So coal tar, this one I think I missed it. This is yes, coal tar. So benzene can be obtained from light oil, which is a fraction of coal tar distillation at around 80 to 70 degree centigrade. Basic and acidic impurities of light oils are removed by treating it first with the acid and then alkali. After the removal of these impurities, the fraction is redistilled. The liquid that is obtained at, because we are getting the fraction at a particular temperature, so at 80 degrees centigrade, the fraction that is obtained is benzene. Okay, now the second one preparation is by your hydroforming or from petroleum or hydroforming or catalytic reforming. This is another chemical commercial method by which benzene is obtained. So the petroleum is, as you know, that it is the mixture of hydrocarbon such as hexane, heptane, octane. These fractions of petroleum contains the hydrocarbon which are heated at around 500 degrees centigrade and 2 atmospheric pressure in the presence of vanadium pentoxide and alumina. Hydrocarbon undergoes cyclization reaction. So why we are calling it hydroforming? Because there is dehydrogenation reaction. So the removal of hydrogen and the formation of alternate double bonds or single bond due because of the cyclization process. So that saturated compound is going to be unsaturated. Means if you are taking hexane, you will get the cyclo hexane with alternate double and single bond, which becomes the benzene 1,3,5 hexa cyclohexa triene, like this. You look at this structure. This structure, you may see this one is your hexane. The first one compound is your hexane at 500 degrees centigrade and 2 atmospheric pressure. You are getting this benzene, and along with it hydrogen molecule is released. Like this, if you have an heptane in the second one reaction, you may get the substituted benzene. Means you have the benzene but along with the one, because in heptane you have 7 carbon atom and in benzene we have 6 carbon. That one carbon, the 7th carbon, becomes the attachment on benzene ring, or you make it is the substituent. So the compound in which the one methyl group is attached as a side chain on benzene is called your toluene. So its common name is toluene. Another one preparation is these two preparation is benzene also going to be prepared from ethine, as we discussed in our last session about the ethine. Ethine on reaction, it produces benzene, one of the compounds. So this one is your, again, bypassing the acetylene through red hot tube. 3 molecules are polymerized like this. This is ethine to C2H2. These 3 molecules. These polymerize means undergo polymerization, which one of the bond from this triple covalent bond is going to make the single bond. It undergoes cyclization reaction and it polymerizes to gives you this structure, which is benzene. We may write a single or double bonds alternately in the benzene ring in hexagon, or you may write it like this, cyclic ring inside. Why this is so? This is just because of the oscillation. What is oscillation? After this, we'll be discussing the structure of benzene, then you will clearly get the uh, understanding. Not only this is a method, one more method by which you are getting the benzene is a high temperature cracking. Cracking, you know, the thermal decomposition of organic compound, which is known as cracking or pyrolysis. When applied to uh, long chain paraffin heated over 6 to 700 degree, various hydrocarbons are obtained, one of which is benzene, toluene, and other. These all are your aromatic compound. So let's discuss the uh, structure of benzene. एज आई टोल्ड यू, जैसे मैंने बताया आप लोगों को कि बेंजीन का फार्मूला है C6H6, बट अगर ऐसे हेक्सेन में देखा जाए या हेक्सीन में या हेक्साइन में तो उनके हाइड्रोजन नंबर डिफरेंट है, कम है. ये क्यों है? व्हाई दिस इज सो? द स्ट्रक्चर analysis and molecular weight determination shows that formula of benzene should be C6H6, while formula of saturated hydrocarbon is like C6H14 or C6H12. This shows that benzene is highly unsaturated compound. So there are two possibilities. As in the screen, you may see this. Structure could be open chain or structure could be cyclic with double or triple bond. When they reacted the benzene like structure with the with that of KMnO4 or bromine like so there arises, for example, it does not undergo reaction with that of the KMnO4. As you know, KMnO4 is used for knowing that the compound is a compound contains double bond or not. So it does not decolorizes the KMnO4's purple coloration. So this shows an open structure for benzene is not possible because it gave no reaction. On treating it with the chlorine or like this halogen, the reaction which is taking place, which is the substituted one like this, the bromobenzene or the chlorobenzene if you are using chlorine. So this shows that because it reacts with that of C6H6, so one of the hydrogen is replaced. Substitution reaction takes place with the help of the bromine, so it gives you the bromobenzene like compound like this or chlorobenzene. So the cyclic structure for benzene is possible then. So this is the only possibility if benzene has a ring of a carbon and to each carbon one hydrogen is attached like this, and benzene only adds up three molecules of hydrogen molecule. Why? Because you are seeing in the benzene molecule we have alternate double bonds. So if you will add up the molecule hydrogen, make it saturated, so one of the hydrogen molecule here, second here, third here, so you will get the saturated compound. So closed structure or the cyclic structure for benzene is possible. In then another scientist, Kekulé, in I think in year 1865, Kekulé suggested a cyclic hexagonal planar structure of six carbon atoms. According to him, to each carbon atom, this each carbon atom there is one hydrogen atom. And this one is closed. ये closed है. Carbon hydrogen नजर नहीं आ रहे structure में, but at each corner there is one carbon present, and to each carbon, Kekulé said, one hydrogen is present. Then Ladenburg, this one is structure. Later, the Lederberg, another scientist in year 1874, objected about the formula by questioning the fourth valency of carbon. When he said in the benzene ring, if there is to each carbon one hydrogen is attached, where is the fourth valency? Look at the structure again. If you may see this, there are no double bond was created by Kekulé. Only he gave this cyclic structure, and this and to each cyclic structure one hydrogen is present. So fourth valency कहाँ है कार्बन की? In order to remove this objection, Kakule proposed alternate double bond in the benzene ring like this. Alternate the single bond to these carbon, then double bond. Single bond and double bond. Now count these its valency of this carbon only. Then their tetravalency, the objection is removed like this. There are one bond this, second bond this, third bond this, and fourth one with that of hydrogen, because to each carbon one hydrogen is present, and to this carbon again we have the four fourth valency is covered like this. One bond this, second bond this, third bond with this, and fourth bond with the hydrogen, to which to each carbon there is one hydrogen. In the similar manner, all all the six carbon atoms are carrying the characteristic of tetravalency. So Kakule's benzene is thus one simply 135 cyclohexatriene. This is what the IUPAC name is 135, because numbering start from the carbon, any of the carbon. If you will start from this carbon, this, here you may give a priority to any carbon, then its name is 135 cyclohexatriene. 1, 2, 3, 4, 5, 6. 1, 3, 5 cyclohexatriene. No matter you are coming from this side or that side, हर साइड से आएंगे, कहीं से भी आएंगे, इसका नेम यही रहेगा, क्योंकि these are the alternate bond and their position is not fixed, they are in oscillation. How now? Objection to the Kakule structure, Kakule formula of benzene is accepted. Then the following two structure can be written for a compound. Which two following structure? Look at these structure like this. If you are attaching the bromine bromination reaction, it is giving you two substituted product like this. अगर ये single bond से attached है, या तो double bond से, या alternate position पे attached है, कैसे भी हमारे पास two possibilities हो सकती हैं कि bromine या तो ये इन single bond से attach हो, या तो इस structure में नहीं है लेकिन ये product सिखा रहा है. मैं यहाँ पे दिखा देती हूँ कि ब्रोमीन अगर इन दो पे या तो अटैच हो, डबल बॉन्ड की साइड पे या सिंगल बॉन्ड की साइड पे, कहीं पे भी अटैच हो सकता है, क्योंकि all are carrying the similar characteristic or oscillation. That's why. Now, what is this oscillation formula? कि ये हम one or two structure draw कर सकते हैं कि यहाँ भी attachment हो सकती है double bond पे भी, कोई भी substitution single bond पे भी हो सकती है. To overcome this objection, Kakule proposed that carbon atom in benzene ring. Again, I am showing the similar weight benzene formula. So Kakule proposed that carbon atoms in benzene ring are in a state of vibration. Vibration, due to this state of vibration, each carbon pair had a one bond half of the time and double bond half of the time, other half of the time. The result is the oscillation of double and single bond like this. Oscillation of double bond, ये double bond यहाँ पे भी हो सकता है, तो फिर यहाँ single bond होगा, यहाँ double bond होगा. So you may write two possible structure, 1 and 2. ठीक है, ये दो possible structure आप बना सकते हैं कि alternate double and single bond, क्योंकि these are in a state of vibration. Or you may put a single, or you may draw dotted line like this कि ये oscillation में है, or you may form a ring inside there. Sorry, you may form a cycle inside the ring like the one in the slide. This one slide like this. You may draw a cycle, a circle inside the ring, hexagon. So this shows that these single and double bond are alternate. They are not fixed at a single position. So they are at alternate position like this. You are seeing this double bond is here, the double bond is here. And then alternate bond, double, single. Here position are different if you are giving position 1, 2, 3, 4, 5, 6. So here you will start the position from here. 1, 2, because double bond, you will give priority to the double bond, and then this one is structure, but both the structure are of benzene. As I told you, no matter कि single और double bond कहाँ पे लगाए गए हैं, कि इसके अंदर साइकिल बनी हुई है inside the ring, the structure remains the same. Let's discuss about the molecular orbital treatment, then it would be very much clear कि oscillation और ये vibration क्यों हो रही है, ठीक है? So the benzene structure is explained by the orbital overlap model of benzene, which gives you, according to the hybridization, benzene structure is best explained on the basis of molecular orbital treatment. According to this theory, the orbital of each carbon undergoes hybridization. The type of hybridized benzene determines the structure of benzene. As you know, in case of sp2 hybridized, जो कि हमने अल्कीन में पढ़ा था, क्योंकि ये डबल बॉन्ड है, तो same states for it. Each carbon is bonded to other two more carbon atom. As you know, this carbon to more other carbon atom. Therefore, the carbon of benzene must be sp2 hybridized. sp2 hybridized. One s orbital and two p orbitals are mixed together to produce three sp2 hybrid orbitals. Okay, there are four partially filled orbital, as you know, in case of carbon, like sp, when we say 1s2, 2s2, 2p1, 2p2. So when you will in the excited state, it becomes like 1s 2s1, 2p1, 2px1, 2py1, and 2pz1. So in this case, the s and 2p get mixed up and gives you three sp2 hybrid orbital, and the fourth one, which is pz, remain unhybridized, as in case of alkene, जैसे उसमें unhybridized pz पड़ा हुआ था. तो अरेंजमेंट ऑफ दिस pz ऑर्बिटल जो हर कार्बन के पास मौजूद है, वन लोब above the plane, one lobe below the plane, one lobe above the plane, one lobe below the plane, सबके पास वो pz ऑर्बिटल है मौजूद, ठीक है? So arrangement of 6 sp2 hybrid orbitals are produced by these 6 carbon of benzene. 6 sp2 hybrid overlap with each other. This will, क्योंकि ये जो भी p orbitals होंगे ये side wise overlap करेंगे and forming a regular hexagonal shape. The orbital of 6 hydrogen atom overlap with the bonds of sp2 hybridized hybrids. In this way, 6cc sigma bond and 6cch sigma bonds are formed like this. Again, I am showing this. Kindly understand this कि ये कार्बन इस हाइड्रोजन के साथ मिलेंगे तो कितने बनाएंगे हमारे, ये 6 के 6 ही कार्बन टू हाइड्रोजन बॉन्ड है, जो कि सिग्मा कोवेलेंट बॉन्ड है, 6 के 6 ही, ठीक है? और ये 6 कार्बन के साथ भी सिग्मा बॉन्ड है, कार्बन का कार्बन के साथ भी. तो व्हाट अबाउट द अदर अनहाइब्रिडाइज्ड ऑर्बिटल, जो कि pz है, हर कार्बन के पास मौजूद है, ठीक है? हर कार्बन के पास जब ये मौजूद है pz जो अनहाइब्रिडाइज्ड ऑर्बिटल है, इट विल साइड वाइज ओवरलैप. ईच कार्बन हैज वन pz unhybridized. अच्छा, one thing that I'm missing here, कि benzene lie in the same plane having an angle of 120 degree, like in the case of alkene, because it is carrying the double bond characteristic and it undergoes sp2 hybrid. sp2 hybridized orbitals के पास कितनी bond angle होती है, 120. Now, what about this 6 unhybridized pz orbital? So each carbon atom has one unhybridized p orbital containing one electron. So there are 6 unhybridized pz orbitals, pi bond, मतलब pi orbitals of 6 carbon atom, which are perpendicular है to the plane of sigma bonds के perpendicular है, ऐसे ऐसे मैं ड्रॉ कर रही हूँ, इसमें बने हुए नहीं है क्योंकि इसमें दिखाया गया है कि still each carbon atom unhybridized है जो कि perpendicular है to the plane of sigma bond. Now one lobe इसकी above the plane है, one lobe below the plane. तो p lobe जो above the plane है, now p orbital of each carbon atom under goes sidewise overlapping with p orbital of adjacent carbon atom. ये दोनों, ठीक है? साइड वाइज ओवरलैप करेंगे, ऊपर वाली लोब्स और नीचे वाली लोब साइड वाइज ओवरलैप करेंगी अपने साथ। फिर ये दो कार्बन के ऊपर वाली लोब्स ऊपर से ओवरलैप करेगी और नीचे वाली नीचे के साथ। ये पिंक और जो ब्लू आप शो कर रहे हैं कि अबव द प्लेन ये सारे जो भी ऊपर वाले कार्बन एटम्स हैं they are sidewise overlapping and making the three pi bonds. Okay, and the जो lower lobes हैं जो कि two lower lobes हैं they will undergo sidewise overlap with p orbitals of adjacent carbon atom on either side to form the pi bond. So this pink and blue color is just for distinguishing कि ये above lobes ने overlap किया and they make up the three pi bond and the below ने भी किया half above the plane and together they are forming the three pi bond and you may draw the two possible structure like this like I showed you. These two possible structure can be drawn after the overlapping of p orbitals. So the structure 1 and 2, if you are giving names structure 1 and 2 are analogous to Kekul's resonating structure. So the overlapping of pz orbital with each other result in the formation of continuous pi bond. This continuous pi molecular orbital half above and half below the hexagon of 6 carbon atom as shown in the figure. So the 6 electron of pz cover all the 6 all the 6 carbon of benzene and are said to be delocalized. These all are the contributing structure which are the said to be delocalized. So energy of this 6 delocalized pi electron is less than the energy of pair of localized pi electron, like in case of alkene with उनकी एनर्जी बहुत ज्यादा थी तो इनकी है 36 किलो कैलोरीज पर मोल. So the benzene structure can be represented by these two resonating structure. Why I am saying this resonating structure, I have explained, but I am telling you once again. So whenever there is a possibility that any structure, or here the benzene, if two or more structure that can be written for a single compound without disturbing its atoms. So here the carbon atom, so that is known as resonance. ठीक है, रेजोनेंस क्या है कि अगर आप किसी भी स्ट्रक्चर के दो या दो से ज्यादा स्ट्रक्चर ड्रॉ कर सकें और उसके स्ट्रक्चर पे या उसके एटम्स पे कोई भी असर ना हो, कोई भी डिफरेंस ना हो, सेम ही हो, तो उनको हम कहते हैं रेजोनेंस स्ट्रक्चर इन केस ऑफ द रेजोनेटिंग स्ट्रक्चर इन केस ऑफ एरोमेटिक कंपाउंड. इसके लिए हमने जो है रेजोनेटिंग स्ट्रक्चर टर्म यूज किया है. ठीक है, सो रेजोनेंस एनर्जी आई हैव रिटन दिस कि ये इतनी कम क्यों है कि वैसे तो बॉन्ड्स की हमारी इतनी होती है और इनकी अगर हम एडिशन दिखाएं कुछ दिखाएं तो इसकी बहुत कम है, इसी वजह से कि बिकॉज दे आर शोइंग दी मल्टीपल स्ट्रक्चर. ठीक है, I have discussed the aromaticity here in slide is also given. Go through this and study it more and more कि aromaticity समझ आ जाए. अच्छा, when there are more fused ring are present, so their names are changed. If look at this, if benzene ring we have the two benzene ring fused together, then we may call it naphthalene. These are the common names. And if three of the benzene rings are in the same manner attached to one another, then we may call anthracene. And then we have this phenanthracene because here they are not in the same manner like that of anthracene, but the one benzene ring attachment is on the double bond. So it becomes the phenanthracene. Here the single bonds attachment and then double bonds. So these are some common names, but all in all, here the structure of benzene and its chemistry is done. And some of the compounds are given for the nomenclature. Okay, now what you have to do in the nomenclature is very much easy. You have to start to give the numbers to the compound like this from the double bond, and then you will give priority to double bond sides होगी 1 2 3 4 5 6 ओके अगर डबल बॉन्ड इधर मौजूद होगा दैट इज द रेजोनेटिंग है so you will go from this side 1 2 3 4 5 6 नो मैटर क्योंकि इसमें बेंजीन में आप नंबरिंग कहीं से भी दे सकते हैं क्योंकि इसमें अभी अटैचमेंट नहीं है व्हेन देयर इज साइड चेन और अटैचमेंट मतलब कोई सी भी जो सब्स्टिट्यूट होके आया है then there is a chance you must start numbering from here. So this is one methyl benzene or you may call it methyl benzene. IOPIC name and its common name is toluene. So in IOPAC system in your exam if it is coming this draw the structure of toluene. So this is the common name toluene. Just draw the benzene structure and attach one of the methyl group over it. So it becomes toluene. This one is ethyl benzene. There is a mistake. There is one more bond which you may draw yourself. Mistake here, and this one is your isopropyl benzene. And in the similar manner, you may give IOPIC name to the benzene like. कि साइड चेन अटैच है साइड चेन का नेम सेम ही रहेगा जैसे अल्काइल में हम दे रहे थे अल्काइल में और वो इस तरीके से आप नेम्स देते ही रहेंगे और we have this compound like this so this one is like 1 2 3 trimethyl benzene and then 1 2 this one is not 3 but this one is on fourth position 1 2 4 trimethyl benzene the structure name is written over here in this slide inshallah I'll send you this slide and now any question if you have any question raise your hand the time is